Hello everyone, I'm Mick Sass, one of the 6 inspectors for RVIA. Today we are going to discuss overcurrent protection within the low voltage systems of our RVs. Wires or conductors for the 12 volt electrical system are routed throughout most RVs. These conductors are designed and built to carry a certain amount of voltage and current. This 12 volt electrical power is carried through stranded electrical wire contained within an insulated jacket. These low voltage conductors or wires are designed to carry a specific maximum amount of current. Current in excess of its design capacity can be caused by electrical shorts, an overload of the circuit, or defective devices. It is very important that the conductors not carry more current than its design capacity. A circuit that is unprotected or becomes overloaded due to inadequate overcurrent protection, the fuses and breakers, can lead to smoking, melting conductors, and potentially fire. Overcurrent situations can occur in the 12 volt system when wiring shorts are caused by frayed wires, or by the repeated bending of the conductors that break the strands of the conductor, or by sharp edges chafing through the wire's insulation. Additionally, shorts can develop because of damage from repeated movement from such items as slide-out rooms. All these potential causes of shorting can create current overloads in the low voltage circuit. However, for today's discussion, we are concentrating on overcurrent protection rather than protection of physical damage to the low voltage wiring. To prevent an overcurrent situation within the low voltage circuits, overcurrent protection devices are required to be installed. Overcurrent devices are intended to trip or burn out as with these blade type fuses. Blade type fuses come in a range of sizes, all marked with their maximum ampacity rating. This fuse, shown here, is a typical 15 amp blade type fuse. When the current flowing through this fuse exceeds 15 amps, the thin fuse wire seen in the middle of the two blades of the fuse housing will melt and break, cutting off current to the circuits it's protecting. Blade type fuses provide overcurrent protection either from individual inline fuse holders as seen here on the left, or, as in the photo on the right, contained in the 12 volt distribution panel side of a combination load center. When either fuses are blown or circuit breakers are tripped, current is cut off to the downstream circuits that they protect. Fuses will always need to be replaced, where a circuit breaker simply needs to be reset. Combination load centers, seen here on the right, house both the 120 volt breakers and the fuses for the 12 volt system. In many cases, 12 volt converters are part of a combination load center. Blade type fuse holders must be marked with the maximum replacement size. This can be done either on the fuse holder itself, as seen here, or in labeling attached adjacent to the wires being protected. With combination load centers, labeling of the replacement fuse size is normally found printed on the door of the load center housing. Another inline overcurrent device is the automotive type circuit breaker. This type of automotive circuit breaker is housed in a sealed plastic body. This specific overcurrent device has a manual reset. The reset button can be seen on the right side of the breaker. If this device senses an overcurrent, it will trip and stop current flow to the downstream conductors on that circuit. With this device, current will only be restored when the reset button is pressed. The plastic-bodied automotive circuit breakers are also made in an auto reset version. With auto circuit breakers, a time delay is utilized based on the heat within the device to reset itself. It should be noted that with both types of these plastic-bodied circuit breakers, the proper connections must be made to the breaker posts. Since low voltage circuits flow in one direction, the battery or the 12-volt power side should always be attached to the copper post as seen marked in this photo. With metal capped circuit breakers, which in this case is also an auto reset breaker, it will only reset itself after a time delay allows the breaker to cool down. These metal cap breakers also come in a manual reset model where the lead from one of the posts must be disconnected in order to reset the breaker. There is another point to remember when utilizing metal cap breakers. The joint between the metal cap and the plastic base of the breaker must be sealed when installed in certain areas of the RV. This is necessary because the metal cap is only crimped onto the plastic base containing the two posts. Crimping does not provide an adequate seal from the sparks produced when the breaker is tripped. For that reason, if a non-sealed breaker is in a battery compartment, which produces hydrogen gases when charging, or in a housing containing propane containers, a non-sealed metal cap breaker is considered a spark producer and are not allowed in those areas of an RV due to the risk of explosion. This short-stop breaker on the right has been coated with a sealant to seal the joint between the metal cap and the plastic base. This is one solution if there is no other location the breaker can be housed. As stated earlier, one cause of overcurrent situations is shorting of the circuit. With any style of automotive circuit breaker, if it is to be located in an area where it could short out because of contact with a metal object between the two posts, a protective cover must be provided. This is commonly storage areas or other exposed locations on the exterior, so covers or protection of some kind must be provided to protect overcurrent devices from weather and any other physical damage. Another type of breaker available is the push-button mini breaker. These are also utilized in the RV industry and are installed in a variety of breaker panel configurations. Many are designed to display an indicator light for the circuit that has been tripped. Blade-type fuses, automotive circuit breakers, and push-button mini breakers all must be marked with their maximum ampacity rating. These markings are required and necessary to assure that when conductors from the 12-volt system are attached, the wire size matches the overcurrent protection. Both the individual fuse holders and the panel boards must match the fuse or breaker rating to the low voltage conductors or wires being protected. Also, note that all current carrying conductors in an RV low voltage system must be stranded wire. The most commonly used wire in RVs are the 14 gauge and 12 gauge wires or conductors. Again, stranded wire is required for all current carrying circuits on the low voltage systems. Table 1 shown here details the size wire and its associated maximum overcurrent protection. The small 14 gauge wire requires overcurrent protection at a maximum of 15 amps. The 12 gauge wire requires overcurrent protection with a maximum of 20 amps. This is standard overcurrent protection based on the ANSI RVIA low volt standard and should be used on all RV low voltage systems. Remember, if a listed piece of utilization equipment, say an LED awning light, provides manufacturer's installation instructions specifying that more overcurrent protection is required than that specified in the low volt standard, the manufacturer's installation instructions must be followed. Also remember that the gauge size of the wire on any overcurrent protection device can always be larger than that detailed in these tables, but it can never be smaller. There are some exceptions to be noted concerning overcurrent protection in the low voltage system. First, any braking circuits for trailers and any cranking circuits, such as engine starters, are not covered by the ANSI RVIA low volt standard. The protection of these circuits still remains the responsibility of the RV manufacturer based on federal and state motor vehicle safety standards. These two items do fall outside the RVIA inspection program and the low voltage standard. Second is that the low voltage standard and the RVIA inspection program do not cover most exterior marking lights that would fall under the Federal Motor Vehicle Safety Standards, FMVSS requirements. This means that trailer and motorhome lighting is not covered by the ANSI RVIA low voltage standard. Only marking lights on truck campers is covered by the RVIA inspection program at this time. However, lights such as exterior porch lights, awning lights, and the electric awning motors themselves are covered by the low voltage standard. In addition, signal wires such as radio wires, thermostat wires, and monitor panel wires are not covered by the low volt standard or the RVIA inspection program. The other exception has to do with the length of pigtails provided with the utilization devices such as lighting, pumps, and motors. For example, recent advancements in lighting have brought on a wide variety of LED lighting which needs to be noted, along with standard lighting that have pigtail connections in excess of 10 inches in length. In particular are the use of LED strip lights that are built into or associated with awnings as seen here. Some of these pigtails that provide connection to the RV's low voltage system are in excess of 6 feet in length and are fitted with 18 gauge wire or smaller. These long, thin gauge pigtails could be and have been in the past attached to 14 gauge wire on 15 amp fuses that supply power to the awning motors. The 15 amp fuse or breaker for the motor is way too large over current protection for these small light gauge awning light wires. These small diameter conductors require overcurrent protection of only 6 amps or less. 15 amp fuses will not protect the wire unless the pigtails have been reduced to less than 10 inches in length. This is the other exception. If the pigtail is less than 10 inches in length, no additional overcurrent protection is required for the pigtail that is less than 10 inches. So, how do you determine the length of a pigtail supplied with the lighting? Standard incandescents, fluorescents, and other lights are all measured from the bulb's receptacle connection to the end of the pigtail. With LED lights, the measurements starts at the first light element, as seen here in the photo on the left. Again, the maximum length of a small gauge pigtail must be less than 10 inches, or the overcurrent protection for the entire length of the pigtail must be appropriately sized. Any pigtail longer than 10 inches must be fused according to the pigtail's wire gauge size. If the pigtail supplied with the lighting or other utilization device is the same gauge as the wire connecting with the 12 volt power, the overall length of the pigtail does not present an overcurrent hazard. low voltage power sources must have overcurrent protection installed within 18 inches of that power source. The battery is the most common power source in the RV industry. As with any wire or conductor that carries current within the low voltage system of an RV, proper overcurrent protection is required. In this example, the overcurrent protection provided is a 30 amp automotive type circuit breaker. It is easily within the required 18 inches. This battery installation and overcurrent protection is done properly. It is protecting a 10 gauge wire that leads to the distribution panel board. When the battery compartment is on the interior of the RV, overcurrent protection still must be within 18 inches, as seen in the top illustration. This measurement is taken along the length of the wire, not in a straight line. When batteries are on the exterior of the RV, say, for example, on the A-frame of the trailer, the overcurrent protection must be within 18 inches of entering the interior of the RV, as seen in the lower illustration. In many cases, however, the overcurrent protection is installed outside on the A-frame near the battery. This provides the protection required throughout the length of the wire, including all wire on the interior up to the distribution panel. Other sources of 12-volt power in RVs are the standalone converters and the combination load centers. Both are designed with built-in overcurrent protection that protects all circuits downstream of those devices. The 12-volt panel board then further reduces the protection size to the individual circuits, with most breakers being 15 and 20 amps that are connected to 14 and 12 gauge conductors respectively. The RV low voltage electrical systems are also designed so that both the converter and the battery power feed 12-volt power to the branch circuits through the same 12-volt distribution panel board. Thanks for attending this mini webinar on overcurrent protection in the low volt system. Please look for this webinar and others on the RVIA Standards YouTube station.